Hello students, welcome back to our channel. Students, in this video we will study a very important topic from class 11th physics from the chapter mechanical properties of fluids, and this topic is viscosity. It is a very important topic, not only for this chapter but in entire physics, and this topic is in chemistry also. So this is a very important topic. Let us understand each and everything about this topic. Let us say we have a fixed surface, right? Fixed surface like ये जो फर्श है हमारा इसकी तरह we have a fixed surface, and in contact with this surface, suppose a fluid is moving. What is a fluid? Anything that can flow is called fluid. By fluid we mean any liquid or gas, because all the liquids and all the gases can flow. So liquids and gases come in the category of fluid. So suppose a liquid is moving, or any fluid, let us say a liquid is moving in contact with this surface. So we will assume the layering structure of a liquid in which one layer moves above the other layer, right? So when the liquid moves, each and every layer slips over the other layer, and due to this an internal friction occurs between the liquid, and that internal friction is called viscosity. For example, suppose you have a bucket of water, and by your hand you are stirring the water in the bucket and the water starts moving. Now if you remove your hand, then the water will come to rest automatically after some time, which means that there is some internal force which is opposing the motion. So there is some internal friction between internal friction in all the liquids, and that internal friction not only in liquids but in all the fluids, and that internal friction of all the fluids is called viscosity, right? Fluids have a layering structure. So when the fluid moves, one layer moves over the other layer, and each layer opposes the relative motion of the layer which this layer is in contact with. So just like the solid friction, when the body is moving on the surface of the other body, then both these bodies oppose the relative motion of each other, and that is what is happening with the layers of the liquid. So this internal friction is called viscosity. So what is happening? Suppose a liquid is moving in contact with this solid surface, and it is moving in layers. It is moving in layers. So layer, the bottommost layer which is in contact with the liquid surface, and by bottommost we mean that the liquid layer which is in contact with the solid surface. Even if the solid surface is like this and liquid is moving on the wall, then obviously we are talking about the wall. So the solid surface with which the liquid is in contact, that surface, the layer which is in contact with that surface, for example ये वाली layer, this layer is at rest because it is in contact with the surface which is at rest. So this surface tends to make the velocity of this layer equal to its own velocity, which is 0, and the layer which is slightly above this layer, that is the second layer, it is moving with some velocity, and this layer is moving with some more velocity, and this layer is moving with some more velocity, and this layer is moving with some more velocity. So as we go away from this surface, the velocity of the layer increases. As we go away from this surface, the velocity of the layer increase. So this has smaller velocity, this has slightly larger velocity, this has more velocity, this has even more velocity. Okay, so let us say there is a layer at a distance, suppose x, at a distance x from the solid surface, and the other layer is at a distance of x plus dx from this surface, which means the thickness of one layer is assumed to be dx. This is the distance x, and this is the distance x plus dx. This is the distance, this whole distance is x plus dx, which simply means that the thickness of this layer is dx. And let us say the velocity of this layer is v and the velocity of the layer just above this layer is v plus dv. So the velocity difference between these two layers is dv, right? Clear? Okay, now let us try to picturize this situation in the form of a three-dimensional figure. So this is the layer and this is the layer below this layer, right? And this is the fixed surface. So this distance is x and this distance is x plus d. This distance is x and this distance is x plus dx, and this velocity is v and velocity of this layer is v plus dv. Now let us say the area of each layer is a. That's why I have shown this in three-dimensional. This is one layer and the area of this layer is a and the area of this layer is also a. So area of each layer is a. So we will discuss a formula for the viscous force which is acting between these two layers. So the viscous force that is the force which is arising due to the viscosity. The viscous force which is responsible for opposing the motion. So what is the formula of that force? Let us say the viscous force is F. Let us say the viscous force is F. So we will say the viscous force F is, or we have observed that the viscous force F is directly proportional to A. That is, viscous force is directly proportional to the area of each layer. More the area, more is the viscous force acting between the layers. Number 2, viscous force is directly proportional to dv by dx, and we know dv is what? dv is the velocity difference between the layers and dx is the distance between the layers. So this dv by dx is a ratio which gives the change in velocity per unit distance. In physics, when anything is expressed with respect to distance, then that value is termed as gradient. So we will call this as velocity. We will call this as velocity gradient. We will call this as velocity gradient, right? Similarly, there are temperature gradients, pressure gradients. Temperature gradient means the change in temperature with respect to distance. Pressure gradient means change in pressure with respect to distance. Like, so this is right. So this is velocity gradient. So if we combine these two, we will get F is proportional to A into dv by dx. F is proportional to A into dv by dx, or we can say F equal to eta A dv by dx. We know that when we remove the sign of proportionality and put an equality sign, a constant has to be multiplied in the formula, and in this case we have multiplied this constant. This is a symbol which is read as eta. The name of the symbol is eta, and the quantity which this symbol is representing is called coefficient of viscosity. Coefficient of viscosity, or simply viscosity, or we call it viscosity also. because this is what? This is the measurement of viscosity of a fluid. If this depends on the nature of the fluid. So value of eta is different for water, different for honey, and different for oil, different for benzene, different for oxygen, right? So this depends on the nature of the fluid. So if the value of this constant, that is eta, is more, then the fluid is more viscous. For example, the value of eta for honey is more than the value of eta for water, which means that honey is more viscous than water. Okay, so we can call it viscosity because it just gives the measurement or idea of the viscosity of the fluid. So this is the formula for viscous force, which is acting between the different layers of a fluid in motion, and this force is responsible for this opposing force which is there between the different layers of a fluid, and that is called the internal friction between the layers. So this eta has the units of Pascal second. For example, how the unit of force is Newton, and we are finding the unit of eta, and the unit of this area is meter square, and unit of velocity is meter per second, and unit of distance is meter. So let's cancel this, and what is the unit of eta? If we shift all the values on the other side, then the unit of eta is Newton per meter square into second. Anna? Newton per meter square into second, and Newton per meter square is what? It is force per unit area, and force per unit area, that is Newton per meter square, it is the unit of pressure, and the SI unit of pressure is what? SI unit of pressure is Pascal. So it is Pascal second. So the standard unit of eta is Pascal second, but the CGS unit of eta, that is viscosity, is very important. So what is the CGS unit? Okay, now let's write this formula once again. Eta A dV by dx. Now let us find the CGS unit of eta. CGS unit of eta. So what is the CGS unit of eta? CGS unit of force is dyne, right? CGS unit of force is dyne and eta, and CGS unit of area is centimeter square, and the CGS unit of velocity is centimeter per second into centimeter. So this is what? This is dyne per centimeter square into second. Dyne per centimeter square into second. Why this unit is important? Because this unit has a smaller name, and that name is very famous in physics. This unit is called 1 poise. So poise is the CGS unit of coefficient of viscosity, and by 1 poise we mean one poise is 1 dyne per centimeter square into second, and there is a very important relation between the SI unit, that is Newton per meter square into second, and this CGS unit, that is poise. Now let's convert this into CGS units. So Newton is dyne. So 1 Newton is what? 1 Newton is 10 raised to power 5 dyne divided by meter square. 1 meter square is what? It is 10 raised to power 4 centimeter square, and this is dyne into second. So this is 10 dyne, this is 10 dyne per centimeter square into second. So this is 1 Pascal second, and this dyne per centimeter square second is what? This is called poise. So we can say 1 Pascal second. 1 Pascal second is what? 1 Pascal second is 10 poise. And 10 is what? 10 is deca. Deca prefix is used for 10. So we can say that 1 Pascal second, 1 Pascal second is 1 decapoise. 1 Pascal second is 1 decapoise. 1 Pascal second is 1 decapoise. Right? So this is what the viscosity is. This was the formula of viscosity, the formula of viscous force, the various units in CGS system and MKS system. So this is a very important topic. I hope this topic is clear to you. I will meet you in the next lecture. Till then, all the very best.